So this is the second video for the final exam review in Stats 251, and we're picking up on the final exam review homework assignment. We're looking at number 6. The first video took a look at numbers 1 through 5. Number 6 wants us to find a 95% confidence interval for the population mean. So here's kind of like the visualization for number 6. If you have a population, so this is all of the population here. There it is. All those dots are all the individuals in the population. They want to know the population mean for what? The mean commute time to work. So here's all of the commuters that commute to work, okay? What's their mean average commute time to work? There's too many of them. Too many people commute to work. I can't measure every commute time. So I take a sample, and my sample size is 27 people. From those 27 people, I can get a sample mean. Remember, the question is, what's the population mean? What's the that's notated by the Greek letter mu. Well, my best guess is to get a sample and get a sample mean. The sample mean time was 31.6 minutes, and not everybody was 31.6. A typical deviation away from that, a standard deviation away from 31.6, would be like 7.1 minutes. This is all given information up in the problem. And then they want us to use a t-distribution to get a 95% confidence interval. So we're going to get a 95% confidence interval, and let's go ahead and use StatCrunch for that. So we're going to go to Stat, T-Stats, one sample, and we just have a summary here with summary. So let's go ahead and do that. Stat, T-Stat, one sample with summary. My sample mean was 31.6. My sample standard deviation was 7.1. My sample size was 27. And I want a confidence interval. My level of confidence needs to be 95% in my case. Yours might be different. And then they give me the low end and high end. They said on the low end, we're 95% confident that the commute time for the population, we know about the sample. This is about the population. We're 95% confident that the population commute time is between 28.79 minutes and 34.41 minutes. All right, that's good. They want that to one decimal place. On the low end, the population mean is 28.8 minutes, and on the high end, 34.4 minutes. Our population mean is somewhere in between there. We're 95% confident in that. The margin of error. Remember what the margin of error is? It's what was your best guess? That's your sample mean. And then how much did you add? How much did you subtract? The amount that you add and subtract should be the same amount to get to 34.4 and 28.8. Remember, our best guess, our sample mean was 31.6. So what was our margin of error? Well, what did we add to get there? What did we subtract to get on the low end? Well, we can just take the difference between the high end and the mean, find out how much did we add. 34.4 minus 31.6. That's 2.8 is how much we added, and 2.8 is how much we subtracted. That's called the margin of error, okay? 2.8. The amount that we added and subtracted to get that confidence interval. how much we added and subtracted from the sample mean to get that range. All right, so remember this is a confidence interval, so we think that the population mean is somewhere between those. With 95% confidence, it can be said that the population commute time is between the bounds of the confidence interval. That looks perfect to me. All right, that's good. That's number 6. Let's take a look at number 7. Okay, now it's a confidence interval on proportions. So now we're talking about not numerical data, but categorical data. In a survey of 5,000, I'll try again. In a survey of 2,560 adults, 1,436 of them said that they have started paying their bills online. Construct a 99% confidence interval. That's a strong confidence interval, but it's going to be wider. I mean, it would be nice if we could narrow it down a little bit, but we got a big level of confidence. Construct a 99% confidence interval for the population proportion. So again, the visualization is this is our population of all individuals. What proportion of them started paying their bills online? I don't know. That's a big question mark. So if I don't know what's going on in the population, maybe I can get a little subset. Maybe I can get a little sample, and I will ask 2,560 people, how many of you have started paying your bills online? And that sample proportion, see that hat, P hat, that means sample proportion. Of those 2,560 people, 1,436 started paying their bills online. Okay, well then, how does that translate to a confidence interval that's 99%? And that confidence interval will have a low end and it will have a high end on the population. We want a confidence interval about the population. So here we go. How are we going to do that? Stat, proportion stats, one sample, and again, we got a summary. All right, so here we go. Stat, proportion stats, one sample with summary. Number of successes. In other words, how many people said, yes, I started paying my bills online this year. That was 1,436 for me. Out of how many? 2,560. And I want a confidence interval. Select confidence interval. Make sure your confidence level is what you want it to be. Mine's 99%. And then they give me the low end and the high end. There it is. So on the low end, we could expect the population proportion of people starting to pay their bill online to be let's see how many decimal places they want this. 3 decimal places. Okay. 0.536. So like almost 54%, right? All the way up to 0.586. So like somewhere between like 53.6 and 58.6% of the people, somewhere in between there is the proportion of people that started paying their bills online for the entire population. Just based on that sample data, we can get information about the population data. All right, so here comes the low end and the high end. 0.536 on the high end. On the low end, 0.536. On the high end, 0.586. Now remember, this is a confidence interval. With 99% confidence, it can be said that the population proportion who started paying their bills online is between the endpoints. And remember, the confidence interval is for the population. It's not about the sample. We know everything there is to know about the sample. This is a confidence interval about the population proportion. All right, so we're good there. All right, that's 6. All right, so now we start talking about hypothesis testing. So number 8 is kind of like our first taste of hypothesis testing. Perhaps I will start the next video with number 8 on hypothesis testing. See you then.